Zeno's paradoxes, a challenge to motion, space, and time. Imagine a world where the very act of moving is called into question. This is the world of Zeno of Elea, a pre-Socratic Greek philosopher who dared to challenge our most basic assumptions about reality. Zeno is renowned for his paradoxes, ingenious thought experiments that probe the limits of our understanding. These paradoxes target our common-sense notions of motion, space, and time, revealing unexpected complexities. Though conceived millennia ago, Zeno's paradoxes remain strikingly relevant today. They continue to fuel discussions about infinity, calculus, and the very nature of reality itself. Consider the simple act of traveling a distance. Before you can reach your destination, you must first travel half the distance. But before you travel half, you must travel half of that half, and so on. This creates an infinite series of ever-decreasing distances. Zeno argued that an infinite number of steps cannot be completed in a finite amount of time. Therefore, according to Zeno, motion is fundamentally impossible. Picture a race between the swift Achilles and a slow tortoise. To make things interesting, the tortoise is given a head start. Intuitively, we know Achilles will eventually overtake the tortoise, but Zeno presents a compelling counter-argument. By the time Achilles reaches the tortoise's starting point, the tortoise has moved further ahead. Achilles must then reach this new point, but again, the tortoise will have advanced. This creates an infinite series of catch-up points. Zeno concludes that the faster runner, Achilles, can never overtake the slower one. Now let's focus on an arrow in flight. At any given instant, the arrow occupies a specific position in space. Zeno argued that time is composed of these indivisible instants. At each of these instants, the arrow is essentially at rest. If the arrow is at rest at every instant, how can it ever be in motion? Zeno's conclusion is that the arrow cannot be moving, challenging our intuitive understanding of motion as a continuous process. Imagine 3 rows of objects in a stadium, moving past each other in opposite directions. This scenario, seemingly simple, reveals surprising contradictions. The paradox arises when we analyze the relative speeds of these rows. The contradictions depend on how we choose to frame and measure the motion. The stadium paradox highlights the complexities of relative motion. It reveals potential inconsistencies in our understanding of space and time, forcing us to question our assumptions. It's crucial to understand that Zeno wasn't literally arguing against the existence of motion. His paradoxes are thought experiments designed to expose the limitations of our intuition. They challenge our understanding of infinity, the nature of space, and the nature of time itself. Zeno's work forced mathematicians and philosophers to grapple with fundamental concepts. These concepts include continuity, infinity, and the intricate relationship between space and time. His paradoxes paved the way for the development of calculus, a cornerstone of modern mathematics. Zeno's insights led to a more sophisticated understanding of motion, moving beyond simple observation. They continue to spark debate and inspire new perspectives on the fundamental nature of reality.